thought I did. And there is a cable on top of my keyboard, I think, and it cuts it off. Okay, so we have a function. We want to find the linearization of this function when a is 4. So all we have to do, remember, this is 4, this is f prime of 4, and this is x minus 4. That's all I need to find. Just plug it in. In addition, I need f prime of a. This is not convenient, but this, to which power, is convenient. This is not a convenient. Excellent. Well done. So then f prime of x, I bring down negative 1/2, and I subtract 1 from negative 1/2. Negative 1/2 minus 1. Negative 50 cents minus $1. Negative 3/2. Okay? Now I have to find f of a, so plug in 4. I have to find f prime of a, plug in 4, and then x minus 4. I put every piece together and I'm done. So let's find f of 4. 1 over the square root of 4. How much is the square root of 4?
2.
Excellent. So this is 1/2. So we have L of x equals 1/2. This piece. This is done. It's 1/2. F prime of 4. I have f prime of here. I have f prime of 4. So let's say this is slightly more difficult. So f prime of 4, let's write it out as negative 1 over 2. Now I have to bring this to the denominator, and it will be the square root of 4 cubed. So I'm plugging in 4 here. 4 to negative 3/2 is 1 over, the 2 is in front, the negative is in front, the square root, this is the square root, but this is the power, 4 to the 3rd. It's negative, so it goes to the denominator. So you can do this in 2 ways. You can say the square root of 4 is 2, 2 to the 3rd is 8, and multiplied by 2. So then f prime of 4 equals negative 1 over 16. Here's another way. 4 to the 3rd is 64. The square root of 64 is still 8. 8 times 2 is still 16. So I found this piece as negative 1 over 16. Here I don't have to do anything, just plug it in. So I have x minus 4. It's almost done, not quite. I have to distribute and add 1/2. And that will be done. Okay, so L of x equals 1/2 minus 1/16 times x. Negative times negative is positive. 4 over 16 is 1/4. I simplify 4 over 16 into 1/4. I continue with L of x, which is 1/2. Sorry, I have to put negative 1 over 16 first. Negative 1 over 16 times x, 1/4 plus 1/2, right? 1/2 plus 1/4, obviously, is 3/4. This is final. What does this mean? This function approximates the original function f of x equals 1 over the square root of x at a equals 4. We say near, basically. Near a equals 4. Not too far from 4. That's it. That's the linearization. Now if we want to continue and answer the rest of the questions, let's go back. Use the linearization to approximate 1 over the square root of 3. So the distance between 4 and 3 is quite big. So I can approximate, and then I will find 1 over the square root of 3, and then find the difference between the two. Any questions? Okay, I have to mute you. Sorry about that. Okay, so we're asked to do 2 things: to find L of 3 and find f of 3. So use the approximation to plug in 3, and then use the function and plug in 3. This is very clear. It's 1 over the square root of 3, and we will approximate it in a minute. And this is negative 1 over 16 times 3 plus 3/4. And we will approximate it in a minute. So back to the graphing calculator. Okay, I just muted everybody, so please stay muted unless you want to say something. Okay, so back to this. This is something I worked on with a student from a different class. Okay, so we have in parentheses, so the easiest part is 1 divided by the square root of 3. And I got 0.57735, enough digits. And the other one is, careful, so negative 3 divided by 16. If you do it like that, you don't need parentheses, plus 3/4, which is 0.75. Now let's see what we get. 0.5625. 0.5625. So, with the linearization, we got 0.5625. The exact function value is 0.57735. As I said, when we say 4, we really mean near 4. Something like 3.9, 4.1. 3 is kind of far. Okay, now final question is asking us to, where is it? It's asking us to, what is the difference between the approximation, here, sorry. What is the difference between the approximation and the actual value? So all I have to do is go back to the calculator and subtract from the approximation. So I'll say minus 0.577350. So the error is negative 0.01485. So that's the difference between the approximation, which was this, and the exact, which was this. Do you feel better now about the linearization?
I do, thank you.
Very good, awesome. So this is done. Good. Do we have other questions that we would like to continue with? Anything from Pearson, anything from anywhere? It doesn't matter. Other questions for me? Other questions?
Can we do?
Yes.
I'm looking, trying to see where it was, but on Monday's class, that we were doing the differential with the dy over dx. Can we do one of those problems? I have the example from Monday.
Oh, yes. I'm ready to do that or anything else.
We've already done that one, but the one that we had from Monday was the 5x squared plus 7xy plus 6y plus 16 minus 5. I just wanted to kind of go over.
You mean this one? So you're talking about implicit differentiation.
Yeah, if we can do a problem like that, that would be great.
Yes. So that's exactly the next in line. That's perfect. So it will be this, implicit differentiation. Very good. So let's do just that. Let's choose a problem with implicit differentiation. And also find the equation of the tangent line. So implicit differentiation, I'm going through the pages here. It's in 3.8, page 359. Perfect. Good. So let's choose anything you'd like. I prefer one with a tangent because you will have one with a tangent. In other words, differentiate implicitly and then find the slope. Find the slope of the tangent to the graph of the curve that is given to the given point. Any problem you would like to choose. From 15 through 28, you choose. If you don't, I will.
I'll take whichever one you choose.
Okay, perfect. So I think we had this one or this one, I don't remember. Is it okay if I choose 28?
Yeah, I think that's the one we actually had, was 28.
This is the one we worked on?
I think, was it the homework problem?
Okay, so homework problems or solutions are posted. So let's choose another then. What about 24?
Okay.
Is that okay?
Yes.
Perfect. So 24 is x cubed minus x squared, y squared equals -9, and the point is given to us as 3 comma -2. Perfect pick. We were supposed to do a problem like that anyway. Excellent. Good. So we are asked to find dy over dx. If you have any difficulties with the concept, it means that y is a function of x. Put a dot under y. So you don't forget that that is a function. It's not a variable. It cannot be treated as a variable. Okay, perfect. So then we are going to differentiate implicitly. Can I solve this equation for y? I can, but it will be a very, I shouldn't say very, but it will be a more difficult situation to deal with. So when I take the square root, I will have plus or minus, and it will be slightly more difficult to differentiate. So I don't even want to find dy over dx. I don't care. I'm not asked to solve for y. It's easier if I use implicit differentiation. So can anyone differentiate x cubed for us? Very good. That's it. That's done. Now when you get here, you have to be very careful, because if you do not identify that this is a product, then the whole thing collapses. What I recommend, because there is a minus in front, leave it alone and open parentheses, and this prime is 0. Open parentheses and then distribute the negative symbol or the negative sign at the end. So when I differentiate x squared, what do I get?
2x.
Very good, times y squared. Then I put plus. I copy x squared, but now I have to be super careful how I differentiate y squared. Can anyone help with y squared?
It would be 2y dx over dy.
Exactly, 2y dy over dx. That's it. So when we differentiate the function to a power, we bring down 2, we subtract 1 from the power, but since this is a function, I have to write dy over dx. Please, I'm kindly asking you, do not write y prime. It's a correct notation, but you may forget or omit this symbol and the whole thing collapses. It's better to use this cumbersome notation instead for implicit differentiation. I know it's cumbersome, I know that this is much easier, but for safety reasons, I recommend please use this. Now I distribute a negative sign. So then I have 3x squared minus 2xy squared minus 2x squared y times dy over dx. And of course, -9 prime is 0. This is the variable. This term will move to the other side. I keep these alone, or I shouldn't say alone, but together on the left-hand side. So this will be 3x squared minus 2xy squared equals, it's negative, goes to the other side, it becomes positive. And now I'm solving for this. Now this is algebra. This step and this step is just algebra. So I just have to write dy over dx. And then evaluate it for the given point when x is 3, when y is -2. Can anyone help? Can anyone help to write dy over dx, or determine dy over dx for us?
Oh, it's 3x squared minus 2xy squared
Yes.
over
Yes.
2xy
2x squared,
Y.
exactly, 3x squared minus 2xy squared, indeed. All I have to do is just plug in those numbers, and be very careful how you plug them in. So, this is 3 squared, which is 9. 9 times 3, 27, minus 2 times 3 is 6. Negative 2 squared is 4. So 4 times 6 over 2 times 9, 18. 18 times negative 2, negative 36. I did this quite fast. I hope my numbers are okay. So 2 times 9, 18. Yes, I think I'm okay. So 27 minus 24, that's a 3, and negative 36, negative 1 over 12. Any questions, please, on this? So what does this represent? It represents the slope of the tangent to this curve, to y. The slope of the tangent at this point. What is the slope? Negative 112, something like this. It's a negative slope, it's a decreasing line. Okay, very good questions. Anything else you would like to work on?
Finding the max and the min again, if that's okay.
Yes, yes. Finding the max and the min on functions, right?
Yes.
Perfect. Let me choose a problem. Very good point. Finding max and min. Okay. So here it is on page 377. Let me share my screen. 377. Let me see how I'm on.